Good day. Today we're going to be looking at thermal expansion and how it might be applicable in the construction world. So if you're a CSM major, something like thermal expansion is something you're really going to want to understand because you're going to have to use it later on in your career. So let's take a look at this practice problem. This is actually a test problem, so you could see something just like this on your test. So the question reads, the coefficient of linear expansion of steel is 12 times 10 to the negative 6th 1 over Kelvin. What is the change in length of a 25-meter steel bridge span when it undergoes a temperature change of 40 Kelvin? So the first thing you're going to want to do in any physics problem, even though we already know we're going to be doing thermal expansion here, is identify what you know and what you're looking for. So the variables that we know here are going to be the coefficient of linear expansion of steel, which is equal to 12 times 10 to the negative 6th 1 over Kelvin. And then we also know that the that the length of the steel bridge is 25 meters. So the initial length is equal to 25 meters. And then the final given is that the change in temperature is going to be 40 Kelvin. All right, and then it says we're looking for what is the change in length of the 25-meter steel bridge. So we're looking for the change in length. So once you have these knowns, you should be able to see that the equation you're going to want to use is the thermal expansion equation. So that, which you should know before your test, is change in length equals the initial length times the coefficient of linear expansion, and then finally times the change in temperature. All right, and so you can then plug these values into the equation because you're searching for the change in length. So delta L equals 25 meters times 12 times 10 to the negative 6th 1 over Kelvin times 40 Kelvin. Sorry, running out of room there. But after you get all these values, you can plug it into your calculator, and you should, if you calculate it right, like I'm doing over here, is get it equal to 0.0, oops, lost my pen there, 12 meters. And then obviously, if you need to change that to centimeters for your question, then you just do a quick conversion, and you could get 1.2 centimeters. And so this is going to be very helpful in the construction world. As you can imagine, if you have a big bridge like this, and during the winter it shrinks 1.2 centimeters, in the summer it expands, or just with concrete or anything like that, it's going to cause a lot of tension and a lot of internal tension within the structure. And that is going to lead, it's just something you need to account for. It can lead to cracking, it can lead to failure of the bridge. And so there's a lot of unique ways within the construction world to help counteract this, which we will be going into in the rest of this Spark page. Thank you so much.